Hi guys, this is June 2022 2H. So question 1, describe fully the transformation that maps A on to B. Okay, so guys, we have to, it's an enlargement for sure. It's a scale factor 3 because you can see 2 of these is the same as 6 of these, or 1 of these is the same as 3 of these. So it's been, the scale factor is 3. The center is the only tricky thing we need to do now, guys. The way we find the center is we join the corners to the corresponding corners, and we continue this line down like this. And then you'll see if we join this corner to this one, and then this one to this one, they'll all meet through here. They'll all meet at the center, and in this case it's this point here, which is 3, 0. So now guys, it's a 3-mark question, so you need 3 bits of information. 1 is enlargement. 2 is the center 3, 0. And then the third one is the scale factor 3. That's your 3 marks. Then he says, on the grid above, translate triangle A by the vector -4, 3. So -4, 3 means we need to go left 4. So let's just look at this top corner here, and we're going to go 4 left. 1, 2, 3, 4. And then up 3, 1, 2, 3. So that's the top corner. Now you could do the same for all the other points. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Or you actually don't even need to do that, guys, because once you've got 1, a translation means it's the exact same shape. So you just draw the exact same shape. It says label your angles, your triangle C. So we'll just call that triangle C. Okay, question 2. Write 1200 as a product of powers of its prime factors. So guys, you can do this. It says show your working clearly, so you obviously have to show your working, but I'm just going to show you how we can get the answer first, just to make sure we're right. So we do 1200 equals shift this, which is the factors. So the answer is 2 to the power 4 times 3 times 5 squared. 2 to the power 4 times 3 times 5 squared. And that is that's the answer, but it's also, that's the answer as a product of its prime factors. Okay, so now we need to show our working. So guys, the way to do this is using the prime factor tree. So 1200, you can go whichever, like there's obviously lots of different factors here. I think just 12 and 100 seems about right to me. Then 12 we do 4 times 3, and 4 we do 2 times 2. Now we stop because these are prime numbers. Then this guy is 2 times, sorry, I was going to do 2 times 10. Let's do 10 times 10, 10 times 10. This guy is 5 times 2, and this guy is 5 times 2. So now clearly you can see that we have a 2, a 2, a 2, and a 2. That's my 2 to the power 4. We have a 3. That's my 3. And then 5 and a 5. That's my 5 squared. So the tree is all you need for your working. Question 3. Alberto, Bill, Candela, and Diana are 4 friends. Here's some information about the height of each of these friends. Okay, Alberto's height, Bill's height, Candela's height is greater than Diana's height. The median height of these 4 friends is 160. The range is 21. Work out Candela's height and Diana's height. Right. So guys, I like to okay, let's put the numbers in a box here. There's 4 boxes. Okay, now it says Alberto's height is 158. Bill's height is 175. Candela's height is greater than Diane's height. The median is 160. Okay, so 160, guys, is here in the middle. So none of them are 160. Now, the range of the heights is 21. Okay, so that means if the range is 21, that means the biggest minus the smallest is 21. Now, I could kind of just guess a few things, guys, but it says Candela's height is greater than Diana's height. So I'm going to put this guy, Bill, I am going to put you, Bill, here, I think. We're going to put you here, 175. Now, if he's the biggest, the smallest must be this minus 21, which is 154. This is 154. Because this minus 21 gives me 154. Okay, so that means that Diana, this has to be Diana D, because Diana, Candela is taller than Diana. So this has to be Diana. He then says Alberto is 158. Okay, so if Alberto is 158, the 158 is going to have to go here in order for there to be a median of 160 there. Because if I put 158 here, it's to the right of the median. So if that's 158, then this has to be 162, because 160 is in the middle of these two. So this is Alberto, this is Bill, and then this is Candela. So Candela is 162. And who's the other one? Diane is 154. Okay. Question 4. These are the numbers in the universal set. A is multiples of 3, B is odd numbers. List the members of the set A intersection B. So this is multiples of 3 that are odd numbers. Okay, so 9 definitely is a multiple of 3 and odd. 12 is not. 15, yes. 18, no. And then we stop. So that's it. 9, 15. A union B. So this is all the multiples of 3 and all the odd numbers. Okay, so first I'm going to write down the odd numbers, guys. Let's do 9, 11, 13, 15, 17, 19, and that's it. And then I need to do the multiples of 3, but I don't include 9 and 15 again. So I'm just going to include 12 and 18. 12 and 18 goes here. Is it true that 24 is an element of A? The reason is no, it is not, because 24 isn't in the universal set. So I'm going to say not, okay, as 24 is not in the universal set. The universal set is basically all the numbers that we're dealing with. Set C has 4 members, such that C intersection not B is 10 and 18. Okay, so guys, I'm going to actually draw a Venn diagram here to make this a bit easier. So here we have this and this. Okay, let's call this B and this C, and this is going to be my universal set. I don't need to worry about A, just forget about A for the time being. Okay, so B is odd numbers, and it says C intersection not B is 10, 18. So this is 10 and this is 18. This is the C intersection, not B. It's what's in C and what's not in B. Now B is all the odd numbers, and we're just going from 9 to 20. So B is 9, 9, 11, 13, 15, sorry, what am I doing? 15, 17, and 19. But C has 4 members. So 2 of these has to be in here. Now guys, which 2 can it be? Well, the answer is any 2. You can pick any 2 and put them there, because now they're still in B, but now C has 4 members. So he just wants us to list one possible set, so I'm just going to do this. It's 10, 18, 15, and 17. These don't have to be in order, guys, but anyway, there you go. Question 5. The diagram shows a shape made from a square and 4 identical semicircles. As shown in the diagram, the semicircles A, B, B, C, C, D, and D, A as diameters. Sorry, it has these diameters. The area of the square is 36. Calculate the total area of the shape. Okay, this, guys, I think is straightforward, right? If the area of the square is 36, that means this is 6. This is 6. This is 6. And this is 6, which means the radius of our circle is equal to 3. So the total area of the shape will be, there's 2 circles. 2 circles. Because there's 2 circles, because if you joined this semicircle to this semicircle, you get 1 circle, and then join this semicircle to this semicircle, you get another circle. So the 2 circles, the area is 2 times pi r squared, because it's pi r squared for 1, and then there's 2 of them. So that's 2 pi times 3 squared, which is 9, which is 9 times 2 is 18, 18 pi. So the 2 circles is 18 pi. The square, well, he tells us, is 36. So the total is 36 plus 18 pi, which is, he wants to 1 decimal place, 36 plus 2 pi is 42. Sorry, it's not 2 pi. What am I doing? It's hang on. Let's just do it again. It's 36 plus 18 pi. 18 pi, which is 92.548, which is 92.5. I'll do this, 92.5 to 1 decimal place in centimeters squared. 92.5. Okay, question 6. Solve this. Okay, first step, definitely guys, multiply both sides by p. So I have 10p equals 3p minus 5. Subtract the 3p and I get 7p equals negative 5. P is equal to negative 5 over 7. That's the answer, negative 5 over 7. Simplify 8 to the power of 0. That's easy, guys. Anything to the power of 0 is 1. Part C. Simplify this. Okay, so we have the 3 and the 6 cancel. 3 into 3 goes once. 3 into 6 goes twice. So it's 1 over 2. X into x goes once. X into x squared goes x. So that's just 1 over x. And then this has to be y squared, because y cubed over y is y squared. And you're left with y squared over 2x, and that's simplified. Factorize this. Common number is 5. 5 goes into 10 and 15. Common c is just c, because there's a c here and here. And then d squared, because there's a d squared here and a d squared there. And I get 2 here. c times c squared gives me the c cubed, and there's no d because I have my d squared, plus 3 to give me the 15. No need for a c because there's only one c, and d squared because d squared times d squared gives me d to the 4. Okay, question 7. Find an expression for x in terms of k and n. Okay, so, right, this isn't that easy, guys. I'm going to change everything into 2 to the power of something. So this is 2 to the power of k, and this is 2 squared to the power of n. Now, all I've done there, guys, is I've said 4 is 2 squared, because 2 squared is 4. Okay, this is then 2 to the k over 2 to the 2n, because I just multiply the powers. And then finally, 2 to the power of k minus 2n equals 2 to the power of x. That is because, well, that's my second law of indices. I just subtract the powers when I'm dividing, k minus 2n. So x is equal to k minus 2n. That's it. K minus 2n. Because if 2 to the power of this equals 2 to the power of that, then this has to equal that. Question 8. A cinema increased the cost of an adult ticket by 12%. After they increased the cost of the adult ticket was this. Work out the cost of an adult ticket before the increase. Okay, so guys, this is reversed percentages, a bit tricky, right? So let's say the initial cost was x. So it was x, the price of the ticket. We increased it by 12%. So we're going to multiply this by 1.12. That's what it means to increase. That's how we increase something by 12%. When we increased it, we got 18.20. So to find x, we just divide. So it's 18.20 divided by 1.12. And this is 18.20 divided by 1.12. 65 over 4, 16.25. 16.25. Okay. Question 9. The table gives information about the population corrected to significant figures of 5 cities. Write this as an ordinary number. Okay, so guys, this is just 8.8 million. 10 to the power of 6 is a million. So we just do 8, 8, 1, 2, 3, 4, 5, because if you do your 8.8 here and you do 1, 2, 3, 4, 5, 6, that's my 10 to the power of 6. But that's 8,800,000 or 8.8 million. Okay, which of these cities had the least population in 2018? Well, the smallest population, I need to first look at, well, these are all in standard form or scientific notation. So I first want to look at the 10 to the power of 6s, because these two have actually got the bigger populations. So I just need to, it's either this, this, or this. And Barcelona has the smallest because it's 5.5. So the answer is Barcelona. Part C. Work out the difference between the population of Tokyo and the population of Ahmedabad. Ahmedabad, sorry, I've never even heard of that city, apologies. Ahmedabad and Tokyo. So that's the difference is this minus this. So it's 3.7 times 10 to the power of 7. 3.7 times 10 to the power of 7. Minus 7.7 times 10 to the power of 6. Now I can do this. It's a 2-mark question, guys. I can do this with my calculator. 3.7 times 10 to the power of 7 minus 7.7 times 10 to the power of 6. And I get 293,000,000 293,000, which is 2.93. He wants his answer in standard form to two significant figures. So let's just be a little bit careful. I'll write this first. It's 2.93 times 10 to the power of 7. Because, again, you can see this. Look, 1, 2, 3, 4, 5, 6, 7. But to two significant figures is 2.9. Because I forget this 3 times 10 to the power of 7. Okay. Question 10. The diagram shows triangle ABP inside the regular hexagon ABCDEF. Work out the size of angle PAF, this one here. Give your answer to three significant figures. Okay, guys, this looks a little bit tricky. First of all, let's consider what we're dealing with. It's a hexagon, and it's a regular hexagon. The interior angles of a hexagon are 120 degrees. This is 120 degrees. I know that because the external, there's a few different ways you can figure that out, guys, but I know the external angle has to be 60 because it's 360 divided by 6. And if that's 60, then this has to be 120 because they add up to 180. So that's 120, which also means this whole thing is 120 there. So if I could just find this angle here, hang on, let's change the color. If I could find this angle here, let's call it X, I can then just subtract that from 120 to give me this angle. Now I know AB is 5 and BP is 2. And this is a right angle triangle. So I can use SOHCAHTOA. So I can say tan X, the tan of this angle, is opposite over adjacent. So that's 2 over 5. Which means X is equal to the inverse tan of 2 over 5. So I want the inverse tan of 2 over 5, 21.8. It's 80, so I'll just put 21.8. I'm not rounding too much yet. 21.8, three significant figures. So now I just need to do 120 minus 21.8, which is 98.2. You can use your calculator. So that angle here is 98.2 degrees. 98.2. Question 11. Cumulative frequency table shows information about the ages of 60 people who went to the gym on Saturday. On the grid, draw a cumulative frequency table. Cumulative frequency graph for the information in the table. Okay, 10 to 20 is 13. So I need to go to 20 and I go to 13, which is there. Try to be as accurate as possible. Then I go to 30, 36, 30, 36, 35, 36. Then 40, 42. This will be 40, 42. 50, 47. 47 is there. 60, 52. 70, 56. You can see these are going up a lot more slowly as we get older. And 80 is 60. Okay, so this kind of makes sense because you wouldn't expect too many people in their 70s going to the gym, but sure, some people do. Now we're going to start at 10 because this guy starts at 10 here, and we're going to join these up and we're going to try and join them in a nice curve. Okay guys, I'm going to try my best here, but you guys try and... Oh, that's actually not too bad. Okay, that's the graph. Then it says use your graph to find an estimate for the median of the ages of these people. Okay, so the median is, if there's 60 people, the median is going to be at 30. So we go to 30, we go across, and we go down, and this looks to be at about 26, 27. The answer says except anything 26, 27, or 28. So I'll go with 26. Okay, so the median is 26. And then he says use your graph to find an estimate for the interquartile range of these people. Interquartile range, 60 people, a quarter of 60 is 15. So I go to 15 and down. Okay, this is, let's say 21. So that's 21. And then I'll go to 45 because that's 3/4 of 60 across and down like this. This is 45. The interquartile range is then 45 minus 25. Sorry, 45 minus 21. Interquartile range is 45 minus 21, which is 24. 24 here. Finally, use your graph to find an estimate for the number of people who are older than 55 years. Okay. Sorry, use your graph to find an estimate for the number of these people who are over 55 years. Okay, so if I go to 55 here, let's go to 55. I go up. Okay, this is almost bang on 50. So this is 50. But it says how many are older than 50. Well, that means there's 50 people younger than 55. Sorry, how many are older than 55? So there's 50 people younger than 55, which means there's 10 people older than 55. That's 10 there. So the answer is 10. Okay. All right, so all my answers are in an acceptable range. Try to draw your graph, guys, a little bit better than me. But there you go. Okay, question 12. ACE and BCD are straight lines. AB is parallel to D. Work at the value of x. Okay, so we have, guys, similar triangles here, because this angle is the same. Okay, let me show you this. This angle is the same as this angle because they're opposite angles. This angle is the same as this angle because they are Z angles, and similarly this angle is the same as this angle because they are opposite. Now, guys, it might actually help to draw out these triangles again just to get your head around what's happening. So this is this triangle here. So this is my DCE, and then beside it I'm going to draw this similar triangle. Now, it's similar because the angles are the same. So in a triangle, if the three angles are the same, then it has to be similar. But just the reason I'm drawing them again is because you can get confused about which is A, B, and C. Like if you just do A, B, C here, you're going to have a problem. So the B, the red angle, the B corresponds to the D. So this is B here. The green angle corresponds to the green angle. So this is C. The C is the same. And the blue, the A, corresponds to this. So this is A. And now we can start putting in our values. So this is 2x plus 9. This is 6. The AC is 1.2. So this is 1.2. And BC is 2x. So this is 2x. Okay. And he says work out the value of x. Work out the value of x. So now I can get the scale factor. The scale factor from the small to the big, let's say, is 6 over 1.2. Now 6 divided by 1.2 is 5. Okay, that's nice. So that means this times 5 equals 6, which means this times 5 equals this. So 2x times 5 equals 2x plus 9, which means 10x equals 2x plus 9, which means 8x equals 9 because we subtract the 2, which means x is equal to 9 over 8. So here we go, 9 over 8. Done. Question 13. The diagram shows a sector AOB of a circle with center 0. Calculate the perimeter of the sector. Give your answer correct to 3 significant figures. So the perimeter, guys, is 5.2 plus this 5.2 as well, because this is also a radius, plus the length. So this question, guys, is really about finding this arc length. Now the arc length, L, is equal to the area, or sorry, the perimeter of the circle, which is 2 pi r, times the angle over 360, because it's that fraction of the circle, 67 360ths. So we've 2 pi, radius is 5.2, times 67 over 360, and this is equal to, out with the calculator, 2 times pi times 5.2 times 67 over 360, which is this, or 6.08. He wants 3 significant figures, guys, so let's just go 6.08. 6.08, and that means the perimeter is equal to 5.2 plus 5.2 plus 6.08, which is this plus 5.2 plus 5.2, which is 16.48 or 16.5. So it's 16.5 to 3 significant figures. Okay, that is question 13. Question 14. Kira throws 4 6-sided dice. The faces of each are labeled with the numbers 1, 2, 3, 4, 5, 6. Fine. Work out the probability that at least one of the dice lands on an even number. Okay, guys, this is worth 3 marks. Now, by far, like you could find the probability that one of them is even. Add that to the probability that 2 of them are even, add that to the probability that 3 of them are even, and add that to the probability that 4 of them are even. But it's much easier if you just go the probability of no even, and then you just do 1 minus this, because he wants the probability at least one is even. So let's find the probability that none of them are even. Now the probability that none of them are even, it's all independent, they're all separate, so I don't have to change the probabilities. The probability that you get an odd number, so a 1, 3, or 5, is 3 out of 6 or a half. So the probability that one of the dice, is odd is a half. But there's 4 of them, so I need to do a half times a half. That's I get 2 odds times a half. Now I have 3 odds times a half. Now I have 4 odds, and obviously you could have just done a half to the power of 4. Multiply this out, you get 1 out of 16. So the probability that you get no even numbers is 1 out of 16. So the probability at least one even is going to be 1 minus 1 over 16, which is 15 over 16, because it's like 16 over 16 minus 1 over 16. And that's it. That was definitely easier, guys, than the other way. Question 15. ABCD is a kite. Calculate the area of the kite. Give your answer to 3 significant figures. Okay, guys, a kite, one of its properties is it's symmetrical. So this, oh, whatever, guys, it won't let me join that nicely to this to C. So anyway, this is symmetrical. So if I can get the area of this triangle, I can just double it. So the area of ABC is equal to, this is the formula from the formula booklet, it's a half times 6 times 11 times sine of 118 degrees. A half AB sine C, that's in the formula sheet. So let's just do this on the calculator. A half is 0.5 times 6, a half times 6 times 11 times sine of 118, close brackets, and I get 29.137. This is 29.137. Therefore, area of ABCD is equal to 2 times this 29.137, because they're the same thing. So this times 2, this times 2 is 58.27, 58.27 to 3 significant figures, 58.3 centimeters squared, 58.3. Question 16. Here are 9 graphs, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. Complete the table below with the letter of the graph that could represent each given equation. Write your answer on the dotted line. Okay, first one, minus 2x plus 3. This one, hopefully, guys, is easy. It's just a straight line with a negative gradient going through 3. So this is a straight line with a negative gradient, but it doesn't go through the y-intercept of 3. This is the y-intercept of 3. So this first one definitely has to be C. Okay, second one, y equals negative 1 over x. All right, 1 over x, guys, is this. This is the graph of 1 over x. You do need to know what this looks like. So minus 1 over x is this one. It's in the other 2 quadrants. It's the same kind of thing. So think of when x is 100, y is 1 over 100. That's why it approaches an asymptote here. And in this one, when x is minus 100, y is minus minus, so it becomes plus. So this one is plus 1 over 100, hence this is the answer to the second part, F. Next one, y equals tan x. You do need to know the tan x graph, guys. It's this one. This is tan. You just need to know what that looks like. That is D. And then finally, x plus 1, x minus 1, x minus 2, right? This is going to be a cubic because my x times x times x gives me cubic. It's a positive cubic, so it's going to look something like this. That's what a cubic looks like. And just in case there's more of those types, let's have a look. No, this is the only one that it could possibly be. But I just want to show you one more thing. This means that the roots are at minus 1, plus 1, and 2. Those are my 3 roots. And look, you'll see minus 1, plus 1, and 2. Those are my 3 roots. So H is the answer to this graph here. Okay, 17. Use algebra to show this equals this, right? Let x equal 0.3454545 dot dot dot. Now that's what these dots mean, guys. The 4 and the 5 are repeated. Okay, then I multiply by 10. So 10x equals 3.4545 dot dot dot. Now the goal is to get the decimals the same. These decimals are not the same. So I go again, multiply by 10 again. And I get 34.5454 dot dot dot. Also not the same. And then finally, hopefully this will be it, I get 345.54 0.4545 dot dot dot. Now look guys, these two, this one, oh, sorry, these decimal places and these decimal places are the same. So I'm going to do this minus this. I'm going to do 1000x minus 10x is 990x. You do this minus this, and then you do this minus this. And the reason you do that is because that the decimals all disappear. My 345.4545 minus 3.4545 gives me 342.0, because the 454545 forever just cancels. Okay, so I'm left with this. Therefore, x is equal to 342 over 990. And I'm guessing, guys, when you put 342 over 990, you get 19 over 55, which is what we wanted. 19 over 55. Okay, only 2 marks for that, guys. That's a bit mean. Right, question 18. Kaidan and Sonia went on 2 different car journeys. For Kaidan's journey, the distance is 80 kilometers and the time is this. For Sonia's journey, the distance is this and the time is this. Kaidan says, my average speed could have been greater than Sonia's average speed. By considering bounds, show that Kaidan is correct. Show you're working clearly. Okay. Fine. Firstly, speed, guys, is equal to distance over time. Now, Kaidan is saying that his average speed could have been greater than Sonia's average speed. So why don't we let's look at the maximum speed for Kaidan. Let's do that. Find max speed for Kaidan and min speed for Sonia. Now what that'll do is if I find his maximum possible speed and her minimum possible speed, then, and this is bigger, then he's right. He could have a faster speed. It's possible that his average speed was faster. So we have to do the whole thing separately, guys. So let's do this, guys. I'm just gonna do Sonia here and Kaidan here. Okay, so this is Kaidan and this is Sonia. Now this is going to be the distance, this is going to be the time, this is going to be her distance, this is going to be her time. Okay, now he has 80 to the nearest 5, so this is 80, the next one is 85, and the next one down is 75. This one's time is 2.7, the next one up is 2.8, next one down 2.6. Now we want his max speed. To get his max speed, we're going to do max distance over min time. So for Kaidan, we're going to get this for distance over min time. Now why that? Well, because we want a big distance over a small time will give me a big speed. So this guy is 82.5, and this guy is 2.65. So his speed is equal to 82.5 over 2.65. Let's just work that out. 82.5 over 2.65 is 31.13. So that's the max speed he could possibly have had. Sonia, on the other hand, her distance was 33 to two significant figures. That means the next one up is 34, and the next one down is 32. And her time is 1 hour, correct to the nearest 0.1 hour. So that's 1 hour. Next one up will be 1.1. Next one down will be 0.9, because we're going 0.1s, 0.9. Now for Sonia, we're going to get the lower bound for distance, which is 32.5, because we're trying to find her min speed, and the upper bound for time, which is 1.15. Her min speed means we want to make the numerator small and the denominator big. So this is speed is equal to distance, 32.5, over time, 1.15, which is 32.5 divided by 1.15, which is 28.26. 28.26. Now, he says his average speed could have been greater than, by considering bounds, show that Kden is correct, as 31.13 is greater than 28.26. Kden is correct. Okay, that's question 18. Question 19. F of x is this, g of x is this, solve f g of x is greater than 0, right? This, guys, I will warn you, is going to be hard because it's a quadratic inequality. First, let's get f g of x. F g of x is, we're going to put g into f. So instead of x squared, it's 2x plus 1 squared. This squared minus 4. And let's just multiply this out, guys. This is, okay, let's do it over here. 2x plus 1 times 2x plus 1 is 4x squared plus 2x plus 2x plus 1, which is 4x squared plus 4x plus 1. And then we do minus 4. So this is 4x squared plus 4x. Well, let's put plus 1 minus 4, which is 4x squared plus 4x minus 3 is 4x squared plus 4x minus 3. Okay, now where is this greater or equal to 0? So 4x squared plus 4x minus 3 is greater than 0. Now again, guys, yes, you're going to have to show the working, but before we do that, let's just get the answer. I can go to the inequality, degree 2. I want greater than 0, so I press 1. I'm going to put 4, 4, and minus 3, and I get x is less than minus 3 over 2, and x is greater than a half. Okay, so x is less than minus 3 over 2, comma, x is greater than a half. Okay, now how do I do that? Well, first I'm going to have to factorize this. Now to factorize this, guys, number of ways to factorize a quadratic. My new preferred way of doing it is like this. I say, let me just change my color. I say a times c is equal to, this is my a, b, c, by the way. A times c is negative 12. Now I need factors of negative 12 that give me 4. So when I add them together. So it's going to be 6 and negative 2, because 6 minus 2 is 4. Then instead of 4x, I write 4x squared. Instead of 4x, I write plus 6x minus 2x. Because 4x is 6x minus 6 minus 2 is 4, obviously. Okay, then I take out the factors of these two terms. So the common factors are 2 and x. Open brackets gives me 2x plus 3. That's 4x squared plus 6x. And then here, there's no common factors, so I can just take out the 1. I'll take out the minus 1 actually, and I'm left with 2x plus 3. And here I have, now I can just write the factors as 2x minus 1 brackets 2x plus 3 greater than 0. And now at this point you can just write down the answer. Now just to kind of clarify why that is the answer, is if you were to graph it, I always say graph these guys. If you were to graph it, you'd have your x here at x equals a half. If you do this equals 0, and if you do this equals 0, you get x is negative 3 over 2, which means I have a 0 at negative 3 over 2, and I have a 0 at a half, which is there. And then when I draw my parabola, guys, hopefully that'll, okay, nice. When I draw my parabola like that, where is this parabola greater than 0? Well, the answer is here, which is x is greater than a half, which is that, or here, which is x is less than negative 3 over 2, which is there. Okay, that is question 19. Question 20. The center O of a circle has coordinates 4, 7. The point A is on the circle with coordinates 6, 11, and AOP is the diameter of the circle. Find an equation of the tangent to the circle at P. Right, first things first, guys. I don't even know what I read. I'm going to draw a circle. Okay, nice. There's a circle. Center is 4, 7. Let's put in the center somewhere there. This is 4, 7. The point A on the circle has coordinates 6, 11. So let's assume we're going 6, 11 somewhere there. This is 6, 11. And AOP, so this is O, and this is A, and P. Okay, let me just move this a bit here, guys, because we're going to draw a line straight across here, AOP, and this is P, and I don't quite have the point yet, but it says find an equation of the tangent to the circle at point P. Okay, I think I can do this, guys. So first, let's find this point P. I can do it because O is definitely the midpoint of this of A and P. So the midpoint means, let's call this X and Y, which means X plus 6 over 2. That's my x1 plus x2 over 2, comma y1 or y1 plus y2, which is 11 over 2. That's the midpoint of A and P using x. That's just using x and y here. This has to equal 4, 7, because the midpoint is O. That means x plus 6 over 2, x plus 6 over 2 equals 4, and y plus 11 over 2 equals 7. And if you just multiply this across, you get 8 minus 6 is 2. So here x equals 2. And here 14 minus 11 is 3. So y is equal to 3. Now, you guys, you could nearly have done that in your head. If you think about it, 2, 4, 6, 3, 7, 11. Anyway, this is 2, 3. Then he says, find the equation of the tangent to the circle at P. Now, the tangent to the circle, guys, is a line that looks like, well, it actually doesn't look like that at all. It looks like, okay, I'm just going to move it. The tangent to the circle looks like that. Okay, now the key point to the tangent of the circle is that this is a right angle. So what I'm going to do is get the gradient. I'm going to get the gradient of PO. The gradient of PO is equal to y2 minus y1, or 7 minus 3. That's y2 minus y1 over 4 minus 2. Over 4 minus 2, which is actually just 4 over 2, which is 2. So the gradient of PO is 2, which means the perpendicular gradient is we flip and change the sign. So if that's like 2 over 1, the perpendicular is minus 1 over 2. Okay, now it says find the equation of the tangent to the circle. So now I have gradient and I have a point. So I can just say y equals mx plus c. I can say y equals m is negative a half x plus c. I know it goes through the point 2, 3, so let's add in 3 for y and 2 for x. 2 for x and plus c gives me 3 equals minus 1 plus c, and that means c is equal to 4. So the equation of the, I'll just write it here, therefore y equals minus a half x plus 4 is the equation of the circle. Question 21. Solve the simultaneous equations. Here we go. So one is a linear equation and the other is non-linear. So guys, we need to combine these. The way to do it is this guy here, rearrange it and make him x equals 3 plus 2y. So if I just add the 2y to the right, I get this. Now I can sub this into x. So I'm going to, let me just show you what I'm going to do. I'm going to sub this in there and in there. Okay, so I get x squared, which is now this 3 plus 2y squared minus y squared plus 2 times, now this becomes this, 3 plus 2y equals 10. Multiply this out. This is 9 plus 12y plus 4y squared. Guys, if you don't know how to do this, just do it at the side. It's 3 plus 2y times 3 plus 2y, and you get 9 plus 6y plus 6y plus 4y squared, which is what I've got there. Okay, this minus y squared plus 2 times 3 is 6, 2 times 2y is plus 4y equals 10. Let's gather all this together. 4y squared minus 1y squared is 3y squared. 12y plus 4y is 16y. And then my 9 plus 6 is 15. Minus 10 is plus 5. So just make sure, guys, you know what you're doing there. Okay, now this is a quadratic, which we need to factorize, guys. I'm going to do it the same way I did just the previous question there. I'm going to say a times c is equal to 15. That's my 3 times 5. Then factors of 15, that gives me 16. Well, that's just going to be 15 and 1. So I break this into 3y squared plus 15y plus 1y plus 5 equals 0. Factors of this are going to be 3y, gives me y plus 5. Sorry, just y plus 5. Then plus 1, and again y plus 5 equals 0. Then the factors are just 3y plus 1 and y plus 5 equals 0, which then leads to 3y plus 1 equals 0, 3y equals negative 1, y equals negative a third, and y plus 5 equals 0, y equals negative 5. So now I have my two y's. To get the x for both of these, here I'm going to use this. I'm going to say x is equal to 3 plus 2 times minus a third. You can use your calculator here, guys, if you want, but this is 9/3 minus 2/3 is 7/3. And here x is equal to 3 plus 2 times minus 5, which is 3 minus 10, which is negative 7. So I'm left with, down here, I'll write x equals 7/3 when y equals minus 1/3. So those two go together. Or x equals minus 7 when y equals minus 5. Those are my two solutions. Question 22. The point A with coordinates minus 3, 2 lies on a straight line. With this equation, find the coordinates of the image of the point A on the straight line with equation f of x minus 3. Okay, so it doesn't even matter that it's a straight line, guys. All that we're doing is we're transforming this point. So minus f of x minus 3 is a translation vertically by minus 3. So that means my x coordinate stays the same, and I'm going to take 3 from the 2. 2 minus 3 is minus 1. Then f of x over 2. This is a horizontal stretch of scale factor 2. So I'm going to, it's this, stretch it times 2. But I multiply my x coordinate by 2. So my minus 3 times 2 is minus 6, and my y coordinate stays the same. Okay, here's a sketch of part of the curve with equation y equals g of x. The point B has coordinates PQ lies on the curve. Find the coordinates of the image of the point B on the curve with equation this. Okay, so there's two things happening, guys. One is a vertical stretch of scale factor minus 1, which actually flips it in the x-axis. So that is a reflection in x-axis. So let me just write these down. Reflection in x-axis. And then this is a translation, a horizontal translation of plus c. Horizontal translation of plus c, because if that's minus c, then it's a plus c. So what happens is this PQ, first we're going to flip it upside down. We're going to reflect it in the x-axis, so it will go, just ignore the writing for a second, somewhere down here. Now what's that point? Well, that point is P minus Q. This is P minus Q. But then we need to move it right. Let's move it right here. C. So now it goes to this point here. Let's just do plus C. So then at this point, the x coordinate gets C added onto it. So that becomes P plus C. And the y coordinate stays the same. That's just minus Q. So we're left with P plus C and minus Q. That's it. P plus C minus Q. Okay, question 23. Express this as a single fraction in its simplest form. Okay. Obviously, guys, this is tricky. So first thing to note is that this is a difference of two squares. X, let's write it here, x squared minus 36 is equal to x plus 6 times x minus 6. If you don't see that, the rest of the questions are really hard. So, I mean, it's really hard anyway, but that's the first step that you need, definitely, right? Once you see that, you can add these two fractions. So this has a common denominator, x plus 6 times x minus 6. That's going to be my common denominator. This is just 20 because that's the same thing. So this is the exact same thing. Now I'm going to make this term here have a common denominator, x plus 6 times x minus 6. And I multiplied the denominator by x plus 6, so I multiply the numerator by x plus 6. Now I'm leaving that for deliberately for a second. Let's just do this. It's 20 minus 2x minus 12, because this is 2x plus 12, and we're minusing it. So it's minus 2x minus 12. So 20 minus 12 gives me 8. 8 minus 2x. Just be careful, guys, with that extra minus. 80 minus 2x times x plus 6 times x minus 6. Okay. Then I'm going to, well, I can rearrange this, guys, into, or sorry, I can factorize the numerator. The numerator factorized is 2 times 4 minus x. So that's 8 minus 2x. And then he wants to, oh, sorry, I should probably leave this here, x plus 6 times x minus 6. And then he wants to multiply it by this. So now we're going to do 2 times 4 minus x over x plus 6 times x minus 6 times 1 over 4 minus x. Now look at that, 4 minus x nicely cancels. This cancels with this, and we're just left with 2 over x plus 6 times x minus 6. And you could argue that, I think you'd get full marks for that, guys, but you could put this x plus 6 times x minus 6 back into this form, which is x squared minus 36. And that's it. Question 24. Okay, this looks long and difficult, guys, right? Oh dear. So the diagram shows a frustum of a cone and a sphere. This frustum shown in the shaded diagram is made by removing the small cone from the large cone. The small cone and the large cone are similar. Fine. The height of the, okay, this is just telling me everything I can see there. Fine. The sphere is divided into 2 hemispheres, each of radius r. Solid A, so this is A here, is formed by joining one of the hemispheres to the frustum. the plane face of the hemisphere coincides with the upper plane face of the frustum. Fine. Solid B is formed by joining the other hemisphere to the small cone that was removed. Okay, fine. The volume of solid A is 6 times the volume of solid B. Given that K is this, find an expression for H in terms of K and R. Right, I think, guys, I don't even need to say this to you, but this is like really, really hard. So, what are we going to do? We need to get the volume of this and the volume of this, and then we can make an equation. To get the volume of this, I need to get the volume of the sphere. Well, the volume of the sphere is, from the formula sheet, 4/3 pi r cubed. That's the volume of a sphere in general. Okay. Now I need to get the volume of the small cone and the frustum. So first, let's get the volume of the big cone. Right, we'll do that. We'll do this down here, guys. The volume of the big cone. Volume of big cone. Now the volume of any cone is 1/3 pi r squared h. So the volume of the big cone is 1/3 times pi. Now the radius is kr, because we're doing the big cone, and the height is kh. Okay, so this is k r squared, and the h is kh. Okay, so this is 1/3 times pi. I have k squared and I have k, so that's going to be k cubed r squared h. That's the volume of the big cone. The volume of the small cone is simply 1/3 pi r cubed h. Okay, that's fine. Volume of small cone is 1/3 pi r squared h. Now it makes sense to me, guys, that the volume of this cone is k cubed times the volume of this cone, because k is actually the scale factor if you look at the similar cones. The radius is k times bigger and the height is k times bigger. Therefore, you'd expect the volume to be k cubed times bigger, because the volume factor is the scale factor cubed. Okay, now the volume of this, let's do actually, guys, the volume of the sphere while we have it. The volume of the sphere is 1/3. It's 4/3. It's 4/3 pi r cubed. Okay, now the volume of this shape is going to be half the sphere, and actually I may as well do the volume of the hemisphere. Hemisphere is half the sphere, so it's just half of this, which is 2/3 pi r cubed. Okay, now solid A is the frustum plus the hemisphere. So let's look at solid A. Solid A. The frustum is big cone minus small cone. Okay, guys, maybe let's do that as well here. Sorry. The volume of the frustum. The frustum. I'm actually just checking my spelling, guys. Frustum. Sorry. The volume of the frustum is the big cone minus the small cone. So it's this minus this. 1/3 pi k cubed r squared h minus 1/3 pi pi r squared h. Now I can take out the third pi r squared h, and I'm left with k cubed minus 1. That's like factorizing. Okay, so solid A is the frustum plus the hemisphere. Volume equals frustum, a third pi r squared h k cubed minus 1, plus hemisphere 2/3 pi r cubed. That's solid A. Solid B is just the small cone plus the hemisphere. Okay, small cone is a third pi r squared h, small cone, plus 2/3 pi r cubed. That is the hemisphere. Okay, now he says the volume of solid A is 6 times the volume of solid B. Okay, let's call this next step equation. We're going to equate this. The volume of solid A. The volume of this is equal to 6 times the volume of solid B. Okay, guys, I think I'm going to probably need to do it down here, because this is a big equation. The volume of solid A, that's this guy here. That's a third pi r squared h, a third pi r squared h times k cubed minus 1 plus 2/3 pi r cubed is equal to 6 times this. So that's 6 times a third pi r squared h plus 2/3 pi r cubed. Okay, and he says the volume of solid A is 6 times the volume of solid B. Find an expression for h in terms of k and r. And he says, given that k is greater than the cube root of 7, I'm not sure why he's given us that, but I guess it's part of this. So we need to find h. That's our goal. Find h. Okay, and he hasn't actually given me that much space. Now let's see what cancels to begin with. So I have a pi in all of these. Great. The pi can disappear. I have an r squared in all of these. Great, the r squared can disappear. This will cancel, but I'm left with 1 r. This r squared disappears, and here I have the same thing. I'm left with 1 r. Okay. Next thing. There's a third. I can multiply across by 3. That will delete all these thirds. So multiply by 3, multiply by 3, multiply by 3, multiply by 3. Okay, now I'm left with h into k cubed plus 1. So what am I trying to find, guys? I'm trying to find h. So h into k cubed minus 1 plus 2r equals 6h plus that's 6h plus 12r. Okay, now nearly done. I'm going to get my h's to the left. So I have a h k cubed minus 1 minus 6h equals 12r minus 2r, which is 10r. Then I'm going to factorize my h, and I'm left with k cubed minus 1 minus 6, which is k cubed minus 7, equals 10r. And finally, And this is actually, guys, why he said k is greater than the cube root of 7. It's just to show that this is positive, because h has to be positive. H is then equal to 10r divided by k cubed minus 7. 10r over k cubed minus 7. Okay, as I said, guys, that was always going to be a difficult question. I think it turned out slightly easier than I was expecting, but yeah, not an easy question at all. 10r over k cubed minus 7. Right. Final question, guys. Question 25. ABCD is a parallelogram, and ADM is on a straight line. Okay, this is, guys, last question of the paper. It's vectors. It's going to be hard. No question. Right. We have AB equals A, BC equals B, and DM equals a half B, right? Let's put this in, guys. So we have, let's say A to B is A. So this vector is A. Now, guys, I'm going to actually move the whole thing over here. It's still that vector, but I'm moving it over here just because there's a K there, and I want to put something else in here when I'm done. Right, so that's A. B is BC, so this is from here to here. This is BC. This is B. And DM is a half B. Okay, let's put, okay, may as well use a different color. DM here is a half B. Now, guys, that means obviously this is B as well, because it's a parallelogram. So that's B there, which also means A to M is 1.5 B, or 3 over 2 B. Okay, now next thing, it says K is the point on AB such that AK to AB is lambda to 1. So that means if you want to think of your ratios, AK over AB equals lambda over 1, which basically means AK equals lambda AB. That's what that means. Now, we know AB is A, so AK is lambda A. So here I'm going to put lambda A. That's the fraction. So from A to K, it's lambda A. It's that fraction of A. And then, okay, I'm going to run out of colors, guys. From K to B, here, this is going to be, well, if it's lambda A to there, what's left is 1 minus lambda A. Because if you add these together, lambda A plus A minus lambda A just gives me A. So this plus this is this. Okay. Right. Then, next thing it says, L is the point in CD such that CL to CD is mu to 1. So that's the same kind of idea. We are going to put, hang on, guys, I really am running out of colors. We are going to put, okay, here we have C to L. This way is mu times A. Now, this A is going this way, so it's negative A going down against the arrow. So this is actually going to be negative mu times A. Okay, he says KLM is on a straight line. So this is a straight line here from K to L to M. Okay, this is a straight line. Let's put in the point M. Let's just put it in like this. Okay, that's M. Okay, now that's important, guys, the straight line, because the way I'm going to do this question is I'm going to say that KL and LM, or KL and KM, are multiples of each other, because if they're going in the same direction, which they must be if they're on a straight line, if they're going in the same direction, then they must be multiples of each other. So I'm going to use that fact to solve this equation, to solve this problem. So what I'm going to do is I'm going to start with I'm going to start with finding KL. Let's start with, actually, I'll start with finding KM, and then I'll find KL, and then I'll make them equal to each other. Now, actually, sorry, one other thing, guys, is, or not equal to each other, but multiples of each other. Given that lambda to mu is 1 to 2, okay, this is just, they've made this question deliberately more complicated than they needed to. They could have just left left one parameter like lambda. So here I have lambda to mu equals 1 to 2. So that actually means mu is 2 lambda. Now just be careful, guys, it's not lambda equals 2 mu. Mu's the bigger one. So that means I need 2 of lambdas to give me 1 mu. Or if you want to see it like this, like you do lambda over mu equals 1 over 2. And then multiply across 2 lambda equals 2 mu. Okay, right, let's get our KL. No, sorry, we'll start with KM. So KM, easiest way to get from K to M is to go down this way and across this way. So I'm going to do KA plus AM. Okay, KA plus AM. KA is minus lambda A because I'm going against the arrow, so it's minus lambda A plus B plus a half B, which is 3 over 2B. That's just 1.5, 3 over 2B. So that's KM. That's from here to here. Now I'm going to do K to L. Now, guys, you could have done like L to M, but it would have required me getting this vector here, which I could have got from this, but let's just stick with K to L, seeing as I have all these drawn, right? So K to L, let us do it here. K to L, I'm going to do KB plus BC plus CL. And that is 1 minus lambda A, 1 minus lambda A plus B minus mu A. But as I said, guys, mu is 2 lambda. So let's just make this minus 2 lambda A. So this is, instead of minus mu A, it's minus 2 lambda A. Okay, I'm going to simplify this a bit, guys. I'm going to subtract this 2 lambda here. So this is actually 1 minus 3 lambda A plus B. Okay, now this is the tricky bit. I have Km and I have KL. Now, the fact that they're on a straight line, as I said, if you multiply KL by something, you can get Km. These are multiples of each other. Now, if they're multiples of each other, then what you multiply the A component by, because A is a vector, has to be the same as what you multiply the B component by. So let's actually write this over here. KL, vector KL, is equal to the vector Km, but wait, they're not equal. If I multiply KL by something, so let's multiply it by X. X times KL equals Km. This is a multiple of this. Okay, fine. Now, what are we multiplying it by? Well, let's have a look. Let's look at the B component. B times, let me do it therefore. Therefore, B times X, or X times B. So if we multiply this B by something, we get 3 over 2B. X times B equals 3 over 2B, which means X has to equal 3 over 2. So that's what we multiply it by. So actually, KL times 3 over 2 gives me Km. So that means 1 minus 3 lambda times 3 over 2, this, the A component, has to give me minus lambda. Now let me just do that, guys, to clarify. This is separate. Okay, so this times the 3 over 2 times the x has to give me this minus lambda. Okay, now let's just solve this and I'll get lambda. So I think I'm going to multiply across by 2. So it's just 1 minus 3 lambda times 3. Let's put this 3 here, and I'm going to multiply across by this 2. So it's minus 2 lambda. 3 minus 9 lambda equals minus 2 lambda. 7 lambda equals, if I add the 9 lambda, minus 2 plus 9 is 7 lambda equals 3. And I'm left with lambda equals 3 over 7. And if lambda equals 3 over 7, remember guys, we have this, mu is 2 lambda, so mu is just equal to 2 of these, which is 6 over 7. Okay, guys, I did tell you this was a hard question, and it certainly was. Okay, that's it, guys. That is the paper complete, and I'll see you in the next video.